Okay, so the topic is glutathione. What's this? And endothelial function. Okay. Let's first consider what are the requirements for our blood flow to be efficient. These are starting with you need a healthy heart because the heart needs to pump the blood, and the heart to function properly. So you need also to have healthy valves in the heart to regulate the flow. And since the heart functions through electrical signals, so you need to have a proper synchronized electrical signals so that you don't have arrhythmia or heart block. Okay, so you're starting with a healthy heart, then you need healthy blood. So the blood itself, you want to pump the blood throughout the body. The blood itself has to be healthy, and in particular, it should not be too thick and should not be clot prone, meaning it shouldn't form clots too easily. And then it should not be loaded with free radicals, toxins, glucose, triglyceride, and bad cholesterol. All this predisposed to clogging up of the blood vessels. And then you need healthy arteries, that part of your circulation from the heart to the organs and tissues. And healthy arteries means not having plaques that block the inside. That means there's no damage to the lining, there's no inflammation, there's no build-up of oxidized bad cholesterol, and there's no build-up of mineral deposits, and there's no clots. And then the wall itself must be supple and able to dilate, no stiffness, and you have sufficient nitric oxide to dilate the blood vessels, not to dilate the arteries. Lastly, would be the veins that bring back the blood. The return of the blood is passive. We only have one pump that pumps the blood from the heart to the organs and tissues. There is no return pump. Okay, so the return is passive through gravity from the parts that is above the heart. It will just come down by gravity. But from the bottom, from the feet upwards, then the blood is pushed up through our muscle activity. Whenever the muscles contract, it squeezes the blood up, and a system of valves prevent the blood from going down again. So the next squeezing of the muscle will bring it further up, and the valves prevent it going down, which means the valves must be functioning well, and you shouldn't have varicosities. Varicosities are dilated parts of the veins. Of course, when they are dilated, means if there are valves there, the valves will be leaking, and there's no valves. It means that the blood is collected stagnant there, right? It's all ballooning up. So these are the basic requirements. For today, we will focus mainly on the arteries because much of the science of the endothelium refers to the arterial endothelium. Okay, so let's look at the coronary arteries in particular, but the same happens in all the arteries throughout the body. So when you look at the coronary artery, you look at the healthy, normal coronary artery, then the lumen or the inside of the arteries is nice and clean. With the lining is the endothelium. The lining, the inner lining of the artery is the endothelium. And then you have the muscle layer, and then you have the outer fibrous layer. And the main problem with coronary arteries is this formation of the plaque called atherosclerosis. That means hardening of the plaque. Okay. There's another term, arteriosclerosis, which means hardening of the arteries. Okay, so slightly different spelling with different meaning. Atherosclerosis, hardening of the atheroma or plaque. So you can see the typical story, and many of us will have some degree of this atherosclerosis. There's the plaque formation, and when the sudden formation of blood clot, then you may have sudden heart attack. Okay. So atherosclerosis affects the whole body, but with our main concern is the brain and the heart. And the heart, it may cause angina and then heart attacks. In the brain, it can accelerate dementia, and then you may have stroke. So symptoms, what are the symptoms of atherosclerosis? It doesn't produce symptoms until the artery is severely restricted or obstructed. You may have chest pain if the coronary arteries are affected. And if the brain arteries are affected, then you may have transient loss of concentration, gradual loss of memory and cognition. And if it's in the legs, you can have painful leg cramps. And if it's in the penis for the guys, then it is one of the major causes of erectile dysfunction. So throughout the body, from head to toe. Okay, let's see the evolution of atherosclerosis. Sorry, yeah, the spelling, there shouldn't be an R there. Okay. First, look at the diagram on the left. That's only showing one side of the cut section of the artery. At the top picture, the topmost part is the inside of the artery. That means that the first layer is the endothelium. It's only one cell thin, one cell thick rather. Okay, the endothelium. Right below the endothelium is a muscle layer, and outside of the muscle layer is the fibrous layer that gives the artery its strength, and the muscle layer gives the artery its ability to contract and relax. Okay, so our concern is this one cell layer of endothelium, right? So the first bad thing that happens is there is injury to this layer. Injury caused by what? By free radicals, by toxins, by inflammatory agents, and by bacteria, viruses, parasites, and many other stuff. So once you have injury, then there is damage, then the body mounts an inflammatory response, which is actually an attempt to repair. Right? So the inflammatory cells come in an attempt to repair. Unfortunately, if the damage continues, so we go in a state of chronic inflammation. So when there is continued damage and continued inflammatory response, then the repair process goes haywire. It's just like, when you have a cut, and then just as about the scar is about to form, the healing scar, then you cut again, then you cut again, and you cut again. Every time the wound is about to heal, you're going to have a deformed scar. So likewise, chronic inflammation leads to a repair process that goes haywire, and then you will have accumulation of fat, which becomes oxidized and hardened, and then you have accumulation of calcium and iron and possibly other metals as well. So you end up with a plaque which is fat laden but hardened because it's oxidized, and then further hardened by the metals, the calcium and the iron. And finally, as the plaque gets big, it may rupture internally, or it may break through the endothelium and cause a clot to form in the narrowed lumen, which may totally block the lumen and cause a sudden heart attack. If the narrowing happens slowly, right, in the evolution of the atherosclerosis, so there is narrowing of the lumen. You can see on the right side, as the plaque gets thicker, the narrowing gets worse. But as this happens slowly, collateral blood vessels tend to form, and sometimes it is enough, right? The collateral flow is enough to compensate, and there is no heart attack, right? And even angina also may be mild. The problem is usually the sudden blockage caused by the blood clot, right? When the plaque ruptures, that usually causes the sudden blockage and heart attack. So our focus here is on the endothelium. You look at the right side, endothelium is the lining, the inner lining of the blood vessel. Here we are referring to the artery. And this is where the starting point of atherosclerosis is. Okay, remember, it starts with damage, injury to the endothelium. If your endothelium is not damaged, is healthy, even if you have high cholesterol, nothing happens. So this will give you an understanding of why some people have high cholesterol, but little or no atherosclerosis. Whereas some other people have normal cholesterol, they still have significant atherosclerosis because they have significant damage to the endothelium, and therefore this process starts. Of course, if you have significant damage to the endothelium and you have high cholesterol, especially high LDL cholesterol and VLDL cholesterol, the very low density, which is worse, and then of course you suffer from a double whammy of risk factors. But between damage to the endothelium and high cholesterol, it is damage to the endothelium which is more significant. Okay, atherosclerosis does not start if there is no damage or injury and inflammation to the endothelium. Okay, if you understand that, then you can understand why people well, there is no simple relation between high cholesterol and heart disease, because there are other factors, and the most important factor here is damage and inflammation to the endothelium. Okay, this is a cross section. So you can see again, here you have on the lower right side, you have that part that is not affected, so the intact and healthy endothelium. And then you have the endothelium that is affected by the process. Below it is the atherosclerotic plaque, and above it is the blood clot, the thrombus, almost entirely blocking the lumen. Right, so and then the blood vessel, of course, is encircled by the elastic smooth muscle layer, which provides the ability to contract and relax, and then the whole thing is protected by the outer connective tissue or fibrous layer. So atherosclerosis is having plaques, which is made of fats and oxidized cholesterol, platelets, cellular waste products, calcium and other metals and other substances deposited in the damaged endothelium. All right, so it starts with damaged endothelium, and then all these things start to accumulate behind it. These deposits further stimulate the cells in the artery wall to produce factors that promote the proliferation of smooth muscle cells and the accumulation of fats. Okay, so one of the response, other than what mentioned just now, is that the muscle layer also tends to get thicker. As a consequence, the artery's diameter may shrink, resulting in disturbances in blood flow and oxygen delivery to tissues. Okay, don't forget, while we are discussing the coronary arteries, the same process happens in the brain and in the other organs also. Right? This is another view of a cross-section of the arteroma, or the plaque that has ruptured. Okay, you can see there's a tear in the artery wall. The artery wall is the endothelium. Okay, so atherosclerosis in the brain causes stroke or brain attack. In the heart, it causes heart attack, right? In the penis, causes impotence, and in the legs, cause claudication, and all this can lead to death. Okay, so now let's focus on endothelial dysfunction. Because you know now, you understand now, the entire story of atherosclerosis, right, which affects the brain, the heart, the penis, the legs, and all the other organs as well, because all organs require arteries to nourish them with blood. And the starting point of damage is the endothelium. So cardiovascular diseases are the world's leading cause of mortality and morbidity, and we know that this problem, atherosclerosis, is not confined to cardiovascular diseases. It affects all the organs. But even if we focus on the impact on the cardiovascular disease, it's already the leading cause of death. Endothelial dysfunction is defined as a diminished production or availability of nitric oxide. The chemical short form for nitric oxide is NO. I usually like to write with a small x beside it, because sometimes when I put NO, people read is NO, yes, no. Okay. With or without an imbalance between the endothelium-derived contracting and relaxing factors. Okay, meaning whilst nitric oxide is the major relaxing factor, there are other factors that affect the ability of the blood vessel to contract and relax. Endothelial dysfunction involved in cardiovascular pathogenesis is a consequence of oxidative stress and inflammation. Likewise, the endothelial dysfunction in all the other organs. Also, the main cause is oxidative stress and inflammation. Endothelial dysfunction and reduced nitric oxide activity are associated with atherosclerosis and its clinical manifestations such as unstable angina. That's when you have regular angina or chest pains. Glutathione improves human endothelial dysfunction by enhancing nitric oxide activity. You must know that nitric oxide is actually a gas in its natural form. There's many functions apart from dilating the blood vessel. Our immune cells use them to fight bacteria and possibly viruses as well. The preservation of endothelial glutathione biosynthesis, meaning the synthesis or the production of glutathione by the endothelial cells, is not only critical for endothelial functions, but studies also show, right, it's also important in preventing fibrosis or hardening of the tissues happening in the lungs and the kidneys, and possibly in other tissues as well. Nitric oxide activity, apart from requiring glutathione, also requires the signals from sex hormones, testosterone and estrogen. This is additional information for you because I happen to be a gynae and also doing a lot of anti-aging work. And for the men need to know, especially that for their erection, they need nitric oxide, which means they need glutathione and they need testosterone as well. Endothelial dysfunction is associated with a vascular damage present in major degenerative conditions such as atherosclerosis. We have discussed a lot about atherosclerosis. because that's where the main issue about endothelial function comes in. But not just arteriosclerosis, even hypertension, right? Depends on healthy endothelium. You know, hypertension has got something to do with the pressure exerted by the heart onto the blood vessels, and the function of the endothelium plays a big role, because the inability for the blood vessel to relax probably is a major contributor to the high pressure. In diabetes, again, much of the damage in diabetes is related to blood vessels. You know, almost all of the complications of diabetes you can group into microcirculatory problems and macrocirculatory problems, okay, related to the small blood vessels or to the larger blood vessels. But they're all blood vessels, and all blood vessels need healthy endothelium. And just aging, the degenerative changes of aging, so much of it is related to the poor functioning of our endothelium. Oxidative distress is the major cause of the impaired vascular function, and the disturbed redox state of endothelial cells, meaning the disturbed balance between free radicals and antioxidants, all right, that will give you the redox state. The disturbed redox state of endothelial cells impairs nitric oxide production, and therefore the inability to maintain adequate vasodilatation. So because oxidative stress is the major cause, then you know that glutathione is a very powerful antioxidant. And indeed, glutathione is found to be the most important restorer of the redox homeostasis or the redox balance in the endothelial cells. Okay, so you can see glutathione has a very, very, very important role in maintaining the health of the endothelium of our blood vessels. It protects against oxidative stress. It protects against chronic inflammation. It fights the toxins that can cause damage to the endothelium. Okay, and of course, it restores the redox balance. Okay, so this is a short presentation. Conclusion. Glutathione is essential. What is this? Glutathione is essential for the healthy function of the endothelium, which is the inner lining of all blood vessels. And blood vessels nourish all the organs and tissues of the body. Therefore, dysfunction of the endothelium affects the health of the entire body. Good. Glutathione protects the endothelium from oxidative damage, toxins, and inflammation. All right, I mentioned this now, and it maintains the redox balance. Glutathione promotes the production of nitric oxide by the endothelial cells, and nitric oxide enables the arteries to dilate, thus improving blood flow and helping maintain normal blood vessel, normal blood pressure, and help for diabetics, and help prevent the complications of diabetes and many more benefits. So therefore, oops, what happened? Okay, I was trying to get rid of this screening. Okay, so therefore, for good blood vessel health and overall health, we need to ensure that we always have adequate supply of glutathione. Okay, that's all for tonight. I don't repeat all that part about what happens to our glutathione as we age, and what is glutathione, and what are the products, because probably we repeat it too often. Okay, that's all tonight.